Hi, I'm Takahiro Haruyama, and he's Hiroshi Suzuki. We work at Internet Initiative Japan, that is a Japanese internet service provider company. Our mission is security incident response, more specifically forensic analysis and reverse engineering malware. We have many targeted attacks using RAT. So today we talk about PlugX, that is frequently used in the attacks. First of all, we introduce ourselves. As I said earlier, we are working on forensic and malware analysis. Sometimes we speak or provide hands-on class at several conferences such as Sun Summit, Black Hat, CIC, FIRST, and things like that. This is today's overview. First, we explain the research motivation. Then we describe the behavior of PlugX, including variants, and how to parse PlugX configuration information. Next, based on the config information, we show the result of two considerations: PlugX sample classification and relationships between classified sample groups and non-attacker groups. Finally, we wrap up our presentation. I explain research motivation. PlugX, also known as CoPlug Garpix, is one of remote access tools used by targeted attacks. PlugX is first acknowledged in the third quarter of 2011. Since then, the PlugX author extends its implementation aggressively. And some security vendors like AlienVault and Unwrap profiled him. Of course, we are interested in who made PlugX, but in this research, we focus on attackers using it. We would like to identify PlugX attacker groups based on configuration information such as C2, installed service name, and things like that. This is a similar approach to FireEye's report about poison ivy attacker identification. However, the task is hard because of the PlugX author's continued update. As you know, there are many PlugX variants in the world. After getting over analysis of 10 different comic size versions and 3 kinds of encryption algorithms, we categorized PlugX samples. Before showing the categorization result, I need to talk about behavior of PlugX. So far, we've observed 3 types of PlugX. We call them type 1, 2, and 3. First, we explain type 1. We observed it since mid-2012. This figure summarizes part of type 1 behavior. When the dropper is executed by exploits or double-clicking, it creates a signed executable and a malicious DLL. We call this DLL PlugX loader. The signed executable is completely inoffensive, but it loads PlugX loader because the DLL is located in the same folder and the DLL name is the same as the one required by the executable. It's called the DLL load order views. As a result, even if we find malware entry in auto startup locations, for example, using autorun, like this, we may miss the malware entry since it is verified. And then PlugX loader decrypts original PE file and its config. We call them PlugX payload. They are only resident in memory. Next, the original PE is executed. It creates process and injects code into the new process. The injection is usually performed twice. First, injected process is decided according to the value in config. Mostly, it's SVC host. The second injected process is MSI exec, that's fixed. Type1 PlugX generates encrypted data table to refer to PlugX payload. The table has signature, gulp, position-independent code pointer that makes arguments in stack before calling shellcode function, original P pointer, and its entry point. The table also has a pointer to config. The type1 config includes C2 setting information and C2 setting URL for downloading C2 information. Install options like install folder path, service name, and other useful information, proxy, injection target, and things like that. Attackers use C2 setting URL such as Dropbox and Baidu. Once PlugX infection is successful and content with C2 information is downloaded from the URL, attackers can delete it. Later, malware analysts cannot get C2 information from the sample. Additionally, the content enclosed by two characteristic strings is uniquely encoded. Unlab searched encoded localhost string, then probably found the test page generated by PlugX author. This ID was the same as that found by Alien board. Interesting. By the way, type1 samples sometimes include several debug strings. For instance, source code file name, function name, and source code file path like this. We can see version and some characteristic Chinese strings in the path. Alien board uses them for identifying PlugX author. As I said before, there are many config size versions in PlugX, but interestingly, a version in the path is not related to the config size. For example, version 8 and version 4 have the same config structure. So we think the version difference stands for just the difference supporting functions. Other strings except version may be connected to signed executable names or operation code names, but we are not sure. Type1 functions are file and register operations, key logging, taking screenshots, remote share. Moreover, pod scan and SQL command are also supported. Besides, as the name suggests, PlugX loads plugin DLL with PLG extension. Type1 uses a flag meaning supported protocols. It seems to support TCP, HTTP, UDP, and ICMP. But ICMP is practically not implemented in Type1. Additionally, the traffic data is encrypted. The encryption algorithm is the same as that of PlugX payload. For the encryption key, double word value is used. It seems like data in hex. If the infected machine is Windows 7 and UAC setting is default, PlugX bypasses UAC pop-up by calling set operation flags and abusing delay load order again. Next, we explain type 2. PlugX type 2 emerged since the third quarter of 2013. This type implements more anti-reversing or anti-forensic techniques than type 1. We explain main features. The original PE in PlugX payload is obfuscated by modifying MZP signatures. Additionally, the signature of encrypted data table gulp is eliminated. So we cannot search the table using the signature. Besides, anti-reversing techniques like string obfuscation and adding API wrappers make the analysis difficult. For example, this function is the same role as type 1 function, but the similarity is 0.4. That means only 40% similarity. So API wrappers lower the similarity. That is an anti-coded thing, we think. Type 2 has changed its encryption algorithm like this. Type 2 config structure is extended from type 1. Type 2 checks magic word in config when sending and receiving packets. The objective may be authentication or target identification. Furthermore, type 2 config holds multiple injection targets. The configuration for screenshots is also added. Lastly, we refer to type 3, another variant of PlugX. This type is very different from type 1 and 2, but based on several common implementations such as protocols and C2 command numbers, we can promise this type is also PlugX variant. Type 3 is observed since the third quarter of 2011. Based on the early emergence, some researchers judge type 3 is ancestor of type 1 and 2. It may be correct, but type 3 is still updated, so we must keep an eye on this type. Main features are this type has no PlugX payload, no encrypted data table, and more advanced anti-reversing, including code obfuscation, shrunk config, but it includes type 2 members like magic word. Supported protocols are TCP and HTTP. The code obfuscation inserts many junk codes. For instance, a simple function calling string copy looks like complicated due to the obfuscation. This is off topic. Type 3 has a de-obfuscated string config this way. The spelling is not correct, so we think the author is not native. This table is a comparison on PlugX types. In my opinion, the author develops two versions separately, type 1, 2, and 3. Based on the difference of time when specific config members or their supporting functions were implemented, we guess the author tried new features in type 1 and 2, then used them in his low-profile version, just type 3. But the truth is the author only knows. We already described PlugX is separated into 3 types, according to the features. Now we explain how to parse the config of each PlugX type. There are some related works about extracting PlugX encrypted artifacts, but for example, PlugX extract decrypts PlugX payload, but does not parse configs. PlugX decoder also does not parse configs, and volatility plugin decrypts then passes type 1 to configs, and 6 config size versions are supported. We implemented 2 scripts for type 1 to Immunity debugger script type 3 is either Python script. We have no time, so skip it. He will speak from here.
Okay. Now we extract PlugX configurations and its code. In this section, we would like to show you how we categorize PlugX samples into some groups and covered links to non-targeted attacker groups. Before we show the result, we need to explain how we classified those samples. We collected PlugX samples from some sources like this. We analyzed 150 samples, but 27 samples are demo versions, so there is no configuration for these samples. As a result, we categorized 123 samples into some groups. How did we do that? We have 3 steps for PlugX classification and association procedure. Step 1, we extracted configurations from PlugX samples with our scripts we mentioned earlier. We used immunity debugger script for type 1 and 2 of PlugX. For type 3, we used IDA Python script. Then we extracted many useful information from all PlugX types, like this. Step 2, we classified PlugX samples as some groups. Step 2 consists of 3 steps. First, step 2A. We made basic groups based on the service name included in the configuration, like this. Second, step 2B, we classified remaining samples moreover with the CNC server information like FQDN, IP address, domain name, and email address of domain owner, like this. Sometimes we use the debug string indicated version path of PlugX we also mentioned earlier. And in step 2C, we repeated step 2A and step 2B until we classified PlugX samples completely, or until we couldn't find any relation. Finally, in step 3, we checked whether the PlugX groups corresponded to non-targeted attackers or not. This is final goal of this presentation, like this. And this is summary of the classification and association procedure. At this time, we had 2 limitations and restrictions when we classified samples. 1, we accepted default service name like SXS, XXX, TVT. 2, we regarded at least 4 samples as a group. And this is a list we used in order to connect to each CNC servers of the PlugX samples and non-attackers. Okay, let's see how we classified PlugX samples as certain groups. This is the complete graph of PlugX correlation diagram, but this is too complicated and chaos graph, right? So we need to explain this graph in detail from now on. We would like to show you some legends of the PlugX correlation diagram we explain from now on. Please remember these icons. Especially, there are 2 important icons. The green icon implies PlugX group we created at this time. And the blue icon implies non-attacker groups. And this is the list of PlugX groups we found at this time. As you see, there are 7 groups. Okay, we describe each PlugX groups. First, cis group. This is the complete graph of cis group. Most samples belonging to cis group use cis string as the service name, like this, MS cis, S cis, Microsoft cis, and so on. And we can also find some network characteristics of cis group, although we classified those samples as cis group using the service name. Let's see that. Some samples belonging to cis group share the domain, like this. moregovernment.com is shared by some samples like this. Next, some another samples share a domain. mg5-yahoo.com. Shared by some samples. And these domains you have seen are managed by the same owner, hlemonk@163.com. Next, we can also find most samples use the same network, this network. These addresses are connected to this network. Okay, this is cis group. Next, WS group. This is the overview of WS group. All samples use WS string as the service name, like this. All samples of WS group share 2 domains as the service name, backgap.com and zesinfo.com. This is also characteristic of WS group. Next, HTTP group. This is complicated one. This is the overview of HTTP group. Some samples use HTTP string as the service name. For example, GWF HTTP, GBF HTTP, and so on. Like this. And some CNC server of HTTP group connect to the same domain, same network, sorry. This network. These IP addresses belong to this network. And some domains are managed by the same owner, winningglobal@gmail.com. These domains are managed by him. And next, sample 69, this, and sample 60 and sample 61 have the same registry value, ASHLD. Note that sample 69 and sample 13, whose service name is GBF HTTP, shares she and his address. So sample 69 is also related to HTTP group, and then sample 60 and sample 61 are also related to HTTP group. Sample 24 use UDP-GF string as the service name, and sample 23 and 53 and 20 use just GF string as the service name. And sample 24 also use UDP protocol to communicate to the CNC server. And other samples use TCP and HTTP protocol. And debug string also have a similar tendency, GF UDP and just GF. So I think sample 24 is UDP variation and other samples are TCP and HTTP's one. Note that sample 24 and sample 16, whose service name is GDY HTTP share domain name of the CNC server, butterfoo.com. So these samples are also related to HTTP group. Okay, this is HTTP group. Next, starter group. This is also a complicated one. Starter group is very big group, right? There are 24 samples. Some samples use starter string as the service name, like this. The CNC server of sample 67, whose service name is starter, and MSN catalogipdate.com is a CNC server of some samples share IP address, this address. And next, accountingrecovery.net is shared by some samples. Sorry. Accountingrecovery.net shared by some samples, including sample 66, whose name is starter, whose service name is starter, and KKorea accountingrecovery.net and iambradley.net connect to this same IP address, like this. The CNC server of sample 71, whose service name is starter, this, and ringm flower-show.org share this address. So flower-show.org is also related starter group. And sample 54 and 55 and 56 use an alphabet after SXS string as the service name, like SXSV, SXSI, SXSB. And these samples also use the same debug string, including ISWORD, like this. Note that sample 56 is related to starter groups. See the previous slide. Okay, these are characteristics of starter group. Next, GraphEdit group. This is the overview of GraphEdit group. All samples use GraphEdit string as the service name, like this. Some domains are managed by the same owner, stefanjerry68@gmail.com, own these domains. Most of CNC servers belong to Amazon EC2 and Unfly IDC. Some CNC servers hosted in Amazon EC2 are in the Japan region as the server's geolocation. And next, coaching group. This is the overview of coaching group. The subdomain of some samples include coaching. For example, coaching back, Cochin E, and Cochin 5, and so on. What is Cochin? This is Cochin, a sort of chicken originated from China. I don't know if this Cochin is related to Cochin group, but this is also Cochin. Anyway, next, 360 group, the last one. This is the overview of 360 group. All samples use 360 string as the service name, like this. That's it. That's it for classification. We have found 7 groups. Now let's take a look relationships between PlugX groups and non-attacker groups. We found some relationships between PlugX samples and the following attacker groups at this time. These are 11 groups or operations. First, Maudi operation. Maudi operation is reported by Norman Shack. Most sysgroup samples and samples 97 not belonging to any PlugX group connect to Maudi operation. hlemonk@163.com and mongolnews@yahoo.com. These domain owners match this operation. Norman Shack said Maudi operation targets Mongolian, Korean, local Chinese interest, and human rights activists. At this time, these PlugX samples and this attacker clearly targets Mongolia or related countries. moregovernment.com, mg5yahoo.com, goodmongol.com, morenews.net. I think More is in short for Mongolia Online. That is news site for Mongolia. And MG implies Mongolia government, I think. Second, 1.php. This incident is reported by this car. Starter group is related to 1.php. One of 1.php poison ivy sample connects to same domain also using starter group. Like this, flower-show.org. 1.php is potentially related to APT1, this scholar said. And Contagio Dump said, flower-show.org targets Japan, China, Taiwan, USA relationships. This picture is fake document appeared for infected person. This message clearly targets Japanese people because this message is written in Japanese. Like this. And this is Happy New Year card for 2010. And there is flower and tiger in this picture. Flower clearly implies flower-show.org and tiger implies year of 2010 as Chinese astrological calendar. East Asian countries, including Japan, use this calendar, so the attacker knows Japanese culture in depth. Third, Sikpot. Sikpot is reported by Symantec. Sample 62 belong to WS group, connects to Sikpot. This is shared by these groups, this address. SIGPOT targets variety countries and industries. At that time, SIGPOT targets mainly US or UK, but unlimited semantic set. And SIGPOT is also related to 1.php. Another poison ivy sample of 1.php is also related to SIGPOT. Next, menu pass. Menu pass is an APT actor using poison ivy reported by FireEye. Menu pass is one of our motivation for this research. Because menu pass targeted our customers last summer, we analyzed this group's poison ivy and PlugX samples, and finally, we specified Sayo.explanum.com is shared by poison ivy and PlugX samples of this group at the same period. If you'd like to know about this incident, you can see our report, IIR, volume 21. And menu pass is also my motivation, not for Haruyama, only for me. Because menu pass often use the poison ivy password Suzuki, according to FireEye, and my name is also Suzuki. Yeah. My boss and colleagues say, hey, are you a menu pass? And are you also a malware analyst? Wow, that is powerful match bomb scary. Yeah. Suzuki is one of the most common names in Japan though. Of course, they make fun of me, but I'm suspected a bit. What a nuisance. Anyway, graph edit group is equal to menu pass, we think. Next, APT1. One of the biggest attacker group reported by Mandiant. Sample 55 belonging to starter group connect to APT1. This address is shared by these samples, these groups. This address. So starter group may be the same as APT1. And next, one of menu pass poison ivy sample has the same IP address as the one used by APT1. This address is shared by these groups. And sample 88, not belonging to any PlugX groups, also connect to APT1. And you can also see another relation to APT1. Many C&C servers of APT1 samples like this, and graph edit group and WS group belong to the same network range. This network range. For example, there are many C&C servers of APT1 in the same range, like this, and another. And sample 6 and 7 of the graph edit group also belong to the same network, like this. And some WS group samples also belong to the same network, like this. And some sample 95 also belong to the same network. Next, Winty. Winty is reported by Kaspersky, targeting game industry. Sample 93 connect to Winty C&C servers, like this. And sample 105 is the one of Winty sample according to Kaspersky. So sample 87 and sample 86 are also related to Winty. Sample 95 potentially related to APT1 sample, we described earlier also connect to Winty. And sample 93 belonging to APT1 also connect to Winty. This address is shared by APT1 and Winty. Next, hangover. Hangover is reported by Norman Shark and other security vendors. Sample 62 belonging to WS group is the same as one of hangover sample according to FireEye. And all samples of WS group, including sample 62, connect to two domains, these domains. So WS group is the same as hangover, we think. Next, Night Dragon. Night Dragon is reported by McAfee, WebSense, and Command5. Sample 95 belonging to Winty is also related to Night Dragon. This domain is related to Winty and Night Dragon. Next, K3chan. K3chan is reported by FireEye. HTTP group and starter group and K3chan sample belong to the same network range. This network range. And IceFog. IceFog is reported by Kaspersky. One of IceFog CNC server is also belonging to the same network range we described in K3chan's part. And the last one, Conquest. Conquest is reported by TSAT. Domain name sword.net using Conquest is owned by winningglobal@gmail.com. This winningglobal@gmail.com also owns some domains of HTTP group. So HTTP group connects to this attack. And sample 21 not belonging to any PlugX groups connect to Conquest. And TSAT said this attack is also related to APT1 mentioned in that report. Okay, that's it for association. This is summary for non-attacker groups we found from PlugX samples at this time. We can see 11 known groups or operations. And this is summary for relationships between PlugX group and non-attackers. We found some relationships from our research. Wow, there are a lot of relations we found. As you can see, almost all groups are related to APT1. Wow. And we also found these 8 samples were related to some non-attackers. But we couldn't find any relationships between 2 PlugX groups and non-attackers at this time. So we need more knowledge samples and more samples and knowledge. Okay, finally, we would like to wrap up this presentation. We analyzed 3 types of PlugX samples, and we implemented PlugX configuration parser for each types. We also categorized samples into some groups based on PlugX configuration and its code. And we found some PlugX groups were connected to known targeted attacker groups. If we use this knowledge effectively, we can take measure against not only a few malware samples related to certain incident, but also entire attack method they use. Because as you have already seen our result, many PlugX group and non-attacker groups are related to APT1. The configuration parser and parser tools and correlation diagram are available on Black Hat archives. So you can download that and use it. At this time, we provide correlation diagram as SVG format. SVG format is a graphic format, but actually this is also an XML format. So you can pass it and use it for incident response. We hope to give you useful information. PlugX is widely used in many incidents, so why don't we, including you, share the analysis result? Okay, thank you for paying attention to our presentation. That's it. Any questions?
Yes.
You said that you saw about 150 different samples. Can you speculate on how so many different variants have been created? Do you think they were created manually or maybe automatically some way?
Oh, sorry. I'm not native, so please speak slowly and
Could you speak more slowly and simply?
Yeah, so you've said that you've seen about 150 different samples of PlugX. Can
Okay.
you speculate on how so many different variants were created? Do you think they were created manually or using some kind of automatic tools for obfuscation or something like that?
Yes, we made a script for extracting PlugX config values automatically. I explained the tools. We made two tools. We categorized PlugX variants into three types, and so the implementations are very different from three types. So for type 1 and 2 debugger script, type 3 either Python script, because type 1 and 2 we can easily search PlugX config in the injected process memory automatically. But type 3 is more obfuscated and anti-reversing, anti-forensic is applied. So we must analyze to find the config statically using IDA-Pro. So we made our IDA Python script for type 3. You can, do you have already CD or DVD including materials? Yes? No? So maybe our tools and diagrams presentations will be available on the Black Hat archive later. Is that
Thank
okay?
you.
Thanks.
Thank you.
Yes. なんですか? Thanks.
Where did you get the malwares from? Your client or virus sorter? Second question is, you categorize by the domain and you analyze domain is related to Mongolian, so targeted Mongolian. I just thinking the point of view targeted organization. The malware used to only one organization or several organizations or the only for financial sector or different sector. Do you have any idea to the malware or attacker group try to the specific sector of the organization?
Yes, you are correct, but there are few samples in our instance. So we collected many of samples from Sandbox or other database such as various ballast total. So we are not sure most of samples are targeted to which organization or companies.
Thank you very much.
Hi. I have a question that you categorize the samples by domains, by IP, and that there's maybe many domains that share the same IP, but that may be a shared host. So how can we show that two domains share the same IP are related to each other? Because maybe it is only on the same host, and then maybe if thinking by that we may think that the category may be incorrect because the two that considered to be related, but actually it's not.
Sorry, could you speak more simply? Sorry.
And we see that you categorize the samples by domains and IP.
Mm-hmm.
So if the two domains share the same IP, we consider that the two samples are related to each other. And what if the two domains are on the same share host? Because because it share the same IP, but it may not related to each other.
Okay. Yeah, of course, it could be. Yeah, but this is PlugX samples, so these are maybe related to each other, I think.
Because actually I actually did some research on malware, and I see that maybe it's the same malware such as PlugX may have different version, different variation.
Mm-hmm.
So maybe different variation be operated by different groups, different attackers. So maybe the two attackers use the same share host, because the two attackers say the same share host.
Yeah, but how can we share the host? The attacker connect each other, so they can connect. They can share the IP address or host or domain or something.
I understand. I mean that the attacker ran a because there are many services online that provide the host. I mean that there are many services that provide the host for people to pay for use the host, and then the provider only use one server, so one IP, but the customer may use different domains to point to that IP and get a different host.
Oh yeah, a domain or something, dynamic DNS or something. You mean?
I mean that there's many host provider that provide a host for many customer, and maybe attackers are among the customer, so they ran a same host, then the same IP, but they use different domains.
It possibly happens, but we use domain or city information as one factor of categorization. We primarily use config values like service name or other information. So the C2 information is used for low priority. So it's not
Okay, okay.
important
Okay.
for us.
Thank you very much.
Okay. Sorry. Any others? Yes.
Your study shows that clearly the command and control centers are known, right? Are you aware of any effort by any organization of going after these command and control centers and shutting them down? And what are the difficulties they encounter?
Sorry, we took no actions about shutting down servers.
But are you aware of any organization that are doing this, going after these command and control centers?
内部でやってるんですよ。いや、多分彼はそういうシャットダウンとか伝えてやってないのって言うんですけど。You mean why we notify? Why don't we notify city information of
For these organizations.
I'm sorry?
Sorry, I couldn't understand your question.
Okay.
Sorry.
Clearly, these infections, right, are reporting back to command control centers, right? So the idea is if you cut off the head, then you cut off the operation. So my question is, how come no organizations are doing effort to shut them down?
Yeah. I know, but we are.
We haven't yet, but yeah.
Yes. Already? Have we already shut down the city servers? Not yet. Is that correct? Yeah.
質問は攻撃を仕掛けてくる、やつの IP アドレスとか分かっているのに、なんでそういうのも、こっちからきちんとそういうふうにシャットダウンするように仕掛ける組織があるのかどうかっていうのを聞いてる。そういう組織を一つでも知ってるかっていう。
だからしてないってことですよ。はい。
Not yet.
We took no actions about shutting down city servers. ありがとうございます。Okay, thanks for coming.